Right now our special products are not going to appear very different from what we just did in the last video, but when we factor these or undistribute these later, I'm going to really focus on the names that I'm about to give us. For our example right now, we really aren't going to notice a difference. We'll just notice something nice and convenient happening. I'm still going to be foiling, I'm still going to be distributing. When I say x times x, I'm going to get x squared. When I say x times negative 3, I'm going to get negative 3x. 3 times x is a 3x. 3 times negative 3 is a negative 9. What's going to happen here? Seems convenient. Negative 3x plus 3x. Sweet. They cancel. X squared minus 9. That's going to be my answer right now. All we'll notice now is this sweet little canceling. To see another problem, if I had 7x minus 2 times 7x plus 2, you'll start to notice, you'll observe that, well, a lot of those numbers are the same, the signs are different. But when we're multiplying these right now, you probably aren't even going to notice too much more of a difference. 7x times 7x, 49x squared. 7x times 2 is 14x. Negative 2 times 7x is negative 14x. Negative 2 times 2 is negative 4. And once again, sweet, they cancel. 49x squared minus 4. And what we're going to notice is all of these numbers, 9, 49, negative 4, that is a 1x squared. If we even look at that 1, 9, 49, and 4 are all squares. What we actually call this is difference, meaning subtraction. Notice in both cases it has to be subtraction. What got those to cancel was the different sign. But remember, when I multiply the different sign, it forces that to be a negative. Not a coincidence. That needs to occur to cancel. That will force that to be subtraction. That's going to be important to us next week. Difference of two squares is what we will call this, because they are both squares. 1 and 9, subtracting. 49 and 4, subtracting. We're going to talk about this name later. Knowing it backwards, this is going to be one of the quick and easy ones to factor. In fact, bailing this out a lot will work later. The next example, x plus 3 squared. Looking a lot like what we did the first week. If I had x plus 3 squared, I tempted to want to say x squared plus 9. That'd be great. But let's show why that's not complete. Remember what squared means. If I were to tell you y squared, you would tell me, oh, y times y. Same thing here. My base is that entire x plus 3. So squared is times itself, x plus 3 times x plus 3. Meaning, FOIL it on out, x squared plus 3x plus 3x plus 9. And what we notice is they don't cancel this time. Inherently, because it's a square, if that's a plus, those are both plus because it's the same thing times itself, meaning they aren't going to cancel, giving me an x squared plus a 6x plus a 9. Notice, without that 6x, and there was an x squared, there was a 9, but without that 6x, it would be wrong. Notice with those binomial squareds, and we'll see this again backwards as well. Our next problem, what if I had 2x minus 9 squared? Remember, squared, as much as I wanted to square those, I cannot do that. I would need to say 2x minus 9 times 2x minus 9. FOIL it on out. 2x times 2x, 4x squared. 2x times negative 9, negative 18x. Negative 9 times 2, negative 18x. Negative 9 times negative 9, a positive 81. When we combine our like terms, 4x squared minus 36x plus 81. There is a shortcut the book may show us. I'm not as worried about shortcuts. I just really want us to focus on some of those routines right now, so when we see these later, we're more familiar with how to address them.